Hello, I'm sure you all know me by now, but my name is Muireann and I am doing my PhD at the University of Cambridge on vertically aligned nanocomposites for voltage control of magnetism that I will tell you about in this video along with my time at BeMAGIC. My PhD focused on novel structures for magnetoelectrics and specifically vertically aligned nanocomposites for magnetoelectrics. So I first started with a van film of a magnetostrictive or ferroelectric matrix with benign nanopillars embedded. I had to weigh these nanopillars and then I can fill that with a ferroelectric or magnetostrictive nanopillars. And this is just a novel way to fabricate magnetoelectric devices, combining materials that are typically grown using pulse laser deposition or PLD and non-PLD compatible materials. So the impact of this work on magnetoelectrics, as we all know, in both the direct and the converse, the mechanical strain elements are so important and we need to maximize the strain coupling. And if you look at the standard structures for magnetoelectrics, one of the main points is the strain transfer, and van or 1,3 structures allow this transfer across a large surface interface and there's no clamping from the substrate. But vans have been limited by weak magnetoelectric coupling and electrically leaky materials by using only PLD compatible materials. So what I've been working on is using PLD grown cobalt ferrite matrix and then filling the pores of that matrix with polymer PVDF to enhance the strain transfer and lower the leakage. So that's one element of my work. The next element of my work was magnetoionics using cobalt ferrite. So instead of cobalt ferrite matrix in this situation, I was using cobalt ferrite nanopillars fabricated in the same way. These pillars are single crystalline and their high surface interface with the liquid electrolyte when doing magnetoionic experiments allows for large ionic migration. So when I apply a negative voltage, the oxygen ions migrate into the liquid electrolyte, and this causes an increase in saturation, magnetization and coercivity, and it's all reversible with a positive voltage. And these results were really interesting. So we found that we can achieve large changes in magnetic saturation and coercivity, and we also achieved more than 2,000 cycles, which is one of the highest for magnetoionic systems. And comparing with polycrystalline cobalt ferrite, which is usually limited to 100 cycles, this is really quite impressive. And if we look more closely at the magnetic properties, we can see that up to applying -10 volts, we can achieve really large changes, whereas the polycrystalline structures achieve considerably less so. So we've created a model system of these single crystalline nanopillars that enhances ion migration in and out of the structure, and also the durability of the single crystalline material enhances the cyclability. So that's the scientific impact. Now the social impact of my work. We all know that Internet of Things, AI and big data really puts a power demand for memory and computing, and that's why the field is looking towards new non-volatile memory. But in these technologies, there's still current needed to read and write data, which leads to joule heating and energy loss. So if we look for new low power computing, such as neuromorphic architectures, well, magnetoionics and magnetoelectrics is a solution to this, as we can get low powered brain-like computing for non-volatile memory. And now the impact of BeMAGIC on my work, and this is my favourite part. So the large cohort has been more than helpful, and there's such a wide variety of research across the whole cohort that it's really helped me build a foundation of collaborators and helped me work in areas that I would have never have expected. presenting to all of you all the time has really given me confidence in presenting, and also I now have the freedom to travel anywhere and explore a wide range of topics, which has been great. Now where I see myself in the future, I hope, now that I've seen a lot of Europe, I hope for a few years to leave Europe, really build up my career, whether it be in postdoc or industry, as I have a wide foundation from this ITN. I hope to go into either quantum sensing, photonics, magnetism, all interdisciplinary work. But then in the long time, I really do hope to move back to Europe, especially move back to Ireland and work for some big research and development companies there. So I just want to say a big thank you so much to all my BeMAGIC cohort, all of the ESRs and all of the PIs. I've had such a good time over the last few years, and I'm really sad that I'm not in Barcelona with you all right now. Enjoy!